Welcome back. We will proceed with the next part, which is about titration curve. What is titration curve? It is a graph that shows how the pH of a solution changes as a titrant is added to a solution of unknown concentration during a titration. There will be two situations that you need to know. The first one is when the burette containing acid while basic solution is placed in the conical flask. To draw the titration curve, it must be drawn pH versus the volume of the titrant, which is the volume of the solution that is placed in the burette. For this case, the titrant is acid, so we need to put volume of acid added. And then we put the unit. It can be centimeter cube or it can be milliliter. Depends on the question what unit it is given. For the y-axis, which is the pH, we need to monitor the pH of the solution inside the conical flask. So this case, it is a basic solution. Before we start with the titration, what would the pH be inside the conical flask? So the pH would be high because it is a basic solution, so the pH will be high. For example, this one, the pH is 12. So initially, we will start with a high pH. When we start with the titration, when we add the acid slowly, so what happened to the pH of the solution inside the conical flask? It will slowly decreasing because of the addition of acid. That's why for the titration curve for this situation, the graph would be decreasing. And this is how the shape of the titration curve looks like. In the titration curve, you also need to label where is the end point. Usually when we have strong acid and strong base solution, they will become neutralized at pH 7. So you need to label where is the end point. So it will be somewhere here, 7. And then you need to write end point. So this is the important part that you need to write in the titration curve. Next, we go to situation 2, where we have an opposite situation. Basic solution is placed in the burette as the titrant, while acid solution is placed in the conical flask. So when you want to sketch the titration curve, it will be the same. pH versus the volume of the titrant, which is the basic solution. So for example, this one, volume of NaOH added. And then for the shape of the graph, since we start with a low pH, and when we add base solution, it will increase the pH of the solution inside the conical flask. So we will have an increasing type of titration curve. This is how it looks like. It will increase. And then you also need to identify where is the equivalence point, which is pH 7. Let's look at this example. A 43 ml of sodium hydroxide was titrated against 32 ml of 0.1 hydrochloric acid. What is the molarity of sodium hydroxide solution? Sketch a titration curve for the reaction and label any significant points. To solve this question, firstly, you need to identify or take out all the information given. So what you can get from the equation is the volume of base, which is 43 ml, volume of acid, 32 ml. The molarity of acid is 0.1 molar. Now you want to know what is the molarity of the basic solution. So first step, you need to write a balanced equation between the hydrochloric acid and sodium hydroxide. So this is the balanced chemical equation. Second step is you need to use the titration formula to find molarity of sodium hydroxide. So you just substitute into the formula. The coefficient would be 1/1 and molarity of basic solution is 0.0744 molar. The next step, you need to sketch the titration curve. Before you sketch the titration curve, you need to identify what is the titrant, which solution is in the burette and which solution is in the conical flask, because it will determine what is the shape of your titration curve. So if you look again at the question, a 43 ml of sodium hydroxide was titrated against 0.1 molar hydrochloric acid. This means you want to titrate NaOH. So NaOH would be placed in the conical flask. We titrate sodium hydroxide against HCl, meaning HCl is placed in the burette. HCl will be the titrate. Since sodium hydroxide is placed in the conical flask, we will start with a high pH. So the shape of the titration curve would be decreasing as in this titration curve. So don't forget to label the curve. So pH versus volume of HCl added because HCl is the titrate. And then the shape is decreasing. Also, you need to label at what pH is the equivalence point. So the pH at equivalence point is 7. Another one thing that you need to label in the titration curve is how much is the volume of the hydrochloric acid needed to neutralize the sodium hydroxide. So you need to look at the equation. Hydrochloric acid used is 32 ml. So you need to label here. The volume of HCl added is 32 ml to neutralize the sodium hydroxide. So this is how you solve this type of question. Do you understand? To check your understanding, you can try this exercise. You have 2 questions that you can try on. The last part for this topic is about indicator. So you already know that indicators are substances that will change color at or near the equivalent point. So there are many types of indicators such as thymol blue, bromophenol blue, methyl orange, chlorophenol blue, bromothymol blue, cresol red, and phenolphthalein. So this is the common indicator used in acid-base titration. For different type of indicator, it will show different type of change of color. For example, thymol blue, the solution will be red in acidic solution while it will turn into yellow in a basic solution. For bromophenol blue, it is yellow in acidic solution and it will turn to bluish purple in a basic solution. The most common indicator that we use in our lab is phenolphthalein and methyl orange. For phenolphthalein, the color is colorless in acidic solution and it will turn into light pink when it reaches the equivalent point, which is when it turns into neutral. While for methyl orange, the color is dark orange in acidic solution. When it reaches neutral or equivalent point, the color would be orange, and then when it is in a basic solution, the color is yellow. And that's the end of this video. I hope you understand for this topic of acid-base neutralization. Thank you for watching.